Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 24, and this problem asks us to name each of the following compounds and state how many lines are observed in its carbon-13 NMR spectra. So let's start with the molecule on the left. So remember naming, we're going to start with the parent chain. So if we look here, and actually if you refer to one of the earlier ones, I think it was problem 4 of this chapter, we know that a benzene ring with a methyl, well that's what we call something that's called toluene. Toluene. So that's the parent chain. We have a toluene, and then if you recall, in respects to this substituent being the methyl group of the toluene, we have two ortho positions, two meta positions, and one para position. So it seems that the second substituent is on a para position of our molecule. So we have a para substituted, and what is this substituent? Well, it's 3 carbons, so it's a propyl group, but it is attached on carbon 2, so it's an isopropyl. So we have para isopropyl toluene. Now, what about the carbon-13 NMR spectra? So in order to determine that, what we need to do is first identify if there's any internal plane of symmetry, and actually there is. So we can see that there is some sort of internal plane of symmetry that goes through the molecule, right exactly through it. So what does that mean? That means that the same type of carbon that's found on one side will be true on the other side. So that means this is one type of carbon, so that means this carbon on the other side will be the same type. Then we have a carbon in the middle here, another carbon in the middle of the plane of the internal plane of symmetry here. Then we have these two meta carbons that are the same. The two ortho carbons are the same. This carbon here is one type, and then the methyl carbon is the last type. So in essence, we have 1, 2, 3, 4, 5, 6, 7 lines on our carbon-13 NMR spectra. Now, what about for this molecule on the right? So what do we have here? Well, we have a benzene ring, we have a hydroxide, we have a hydroxide anion, and we have a nitro group. So starting with the benzene ring as the parent chain, we know that a benzene ring with a negatively charged oxygen, well, that's a phenolate parent chain. So remember, phenol is just another name for benzene. And then when we have 8, that just means it's a negatively charged, so this O minus group here. And what do we have on this? Well, we have, so if this is carbon number 1, where the negatively charged oxygen is. We count 1, 2, 3. So in carbon 3, we have a hydroxide group. So we have 3 hydroxy. And that's 3, 4, 5. Carbon 5, we have a nitro group, 5 nitro phenolate. So we have a 3 hydroxy, 5 nitro phenolate group here. Now, what about the carbon identities? Well, if you look at this, we actually can determine that each of these carbons are going to be unique. And we know this because this carbon is adjacent to hydroxide and the oxygen anion. This carbon here is adjacent to a negatively charged oxygen and a nitro group. This carbon here is directly bonded to a nitro group. This carbon here is bounded to is adjacent to a hydroxide and a nitro. And then finally, the last carbon is directly bounded to hydroxide. So in essence, what we have is 6 different types of carbons, including this one here. So we'll have 6 peaks in our carbon-13 NMR spectra.